All right, in this video we're going to be talking about waves. This is an introduction to waves. A wave is going to be basically a repeating disturbance or movement that transfers energy through matter or space. So for example, ocean waves disturb the water, so that's what we mean by a disturbance, and then transfer energy through it. Or during earthquakes, energy is transferred in powerful waves called seismic waves, which we sort of see here, that end up traveling through the earth. Waves transfer energy between molecules that are actually touching each other. So in sort of our example here at the bottom, a pebble might fall into the pool of water, and then because it is moving and therefore has kinetic energy, it also has mechanical energy. And if you remember, mechanical energy is the ability to do work on other objects. And so the pebble then transfers some of its energy to the water molecules that it touches, causing them to move. And then those molecules transfer the energy. So here, some of these move, and then others of those move, etc. Those molecules transfer the energy onto their neighboring water molecules, causing those to move, and therefore the energy moves further and further apart and further from the original disturbance, as you can see here in these ripples, which start out in the center and then get larger and larger and also further away from the original disturbance. So something you need to know, waves don't actually move the actual molecules in the object through the medium that they're moving through, okay? So for example, it doesn't move the object this way, it actually only moves the energy through the wave, okay? So all waves actually have this property. They carry energy without actually transporting matter. Well, you might say, well, we actually just talked about matter moving, and they will move, but at the end of their movement, they will end up in the exact same place they started. So for example, here's this gentleman here doing this rope exercise, and he's going to move the ropes up and down, which causes this wave here. But when, say for example, this molecule here in this part of the rope, when it's done moving, it'll be in the same place, and it'll be in the same place on the rope. This molecule didn't jump to this place on the rope. It is staying in the same place within the rope, even though it moved, not within the rope though. It went up and down, but it stayed in its similar position on the rope. It's just the whole rope that moved, and then it stops. The molecules in relation to each other on the rope don't move, just the energy. And so a wave will travel as long as it has energy to carry. So when you drop a pebble into the puddle, the ripples will eventually die out and the surface will become still again after there's no more energy to carry and most of it has been transferred away. For example, moving the exercise ropes, unless the person continues to move the rope from their end and therefore is putting energy into the system, the ropes will also stop moving eventually once all the energy has been transferred. And as you might have noticed, the medium here is basically going to be the matter that the waves travel through. So for example, sound waves, which are allowing me to talk to my iPad right now, are traveling through air. The ocean waves travel through water. A medium can be solid, liquid, or gas. So I just named a gas, I just named a liquid. An example of light waves, for example, traveling through a solid will be if you wear glasses or have ever used a magnifying glass, or when we use microscopes in biology, you're going to see light waves traveling through the solid lenses, okay? So that's waves traveling through air, liquids, and gases. And waves that can only travel through matter are called mechanical waves. In a bit, we'll end up talking about waves that can travel when there's no matter. So, here are the two main types of waves. The first here is transverse waves, where the matter in the medium moves back and forth at right angles to the direction of wave travel. So if the direction of wave travel is this way, the molecules are moving up and down perpendicular to that. So right here we have a transverse wave. Say I shook the hand over here, the wave will travel overall in the horizontal direction, but the molecules here are traveling up and down perpendicular to that. Another type of wave is going to be a longitudinal or compressional wave. And so in these waves, the matter in the medium moves back and forth in the same direction that the wave travels. So this is like pulling or compressing this sort of spring here, or if you think of a slinky. Here, the overall direction of the wave is going this way. If I start at one end moving back and forth, eventually that'll propagate the entire length of the spring here. And the waves themselves, these molecules are moving to and fro, but along the same sort of line that the wave is propagating.